When we're trying to solve rational equations, the best thing to do is get rid of the fractions. In this first example, 4 over 3x plus 1 is equal to 2 over x minus 5. Because we have one fraction equal to another fraction, this is just a proportion, so we can solve it by cross multiplying. That means 4 will get multiplied by x minus 5, and that'll be equal to 2 getting multiplied by 3x plus 1. Without any more fractions, we solve this like normal, distributing and distributing on the right side, then subtracting the 4x to get all the x's on one side, and subtracting 2 to get all the coefficients on the other side. That'll leave negative 22 is equal to 2x. We finish this one up by dividing both sides by 2. So x is equal to negative 11. You should quickly check to make sure that this solution didn't make either of our denominators equal to 0, but 3 times negative 11 plus 1 is not 0, and negative 11 minus 5 is not 0. So we're good. When the rational equation is not a proportion, we still want to get rid of the fractions, and the best way to do that is to multiply through by the common denominator, and I mean the common denominator of all the fractions. So in this case, our common denominator is going to need a 3x and a 2. So I'm going to multiply every term by 3x times 2. Because I multiplied through by the same thing on both sides, we're still following the rules of solving equations. But we can cancel these denominators, like 3x is canceling with 3x. This 2 will cancel with this 2. And 2x will cancel with the 2 and the x. So our equation has turned into 2 times 1 plus 3x times 2 is equal to 1 times 3. A much simpler equation to solve. So we'll have at it by subtracting 2 from both sides. 6x equals 1. And then dividing both sides by 6. So x is equal to 1/6. So the most complicated that this could look like would be like what we have here, where the denominators are not factored at all, and we've got polynomials all over the place. So the best thing to do is we're going to have to multiply through by the common denominator, but without factoring we don't know what it is. So I'm going to factor each of the denominators, which is really just the first denominator, into x minus 5 and x minus 3. All the other fractions are going to stay the same. Now I'm going to go through and multiply every term by the common denominator. And that common denominator is going to need an x minus 5 and an x minus 3 in it. And that'll be it. Now, cancel everything that we can out of the denominators. In my first fraction, both the x minus 5 and the x minus 3 will cancel. In the second fraction, it's only the x minus 5. And in the last fraction, it's only the x minus 3. So we can rewrite the equation as 7x plus 3 plus 3x times x minus 3 is equal to negative 1 times x minus 5. It's not exactly a super easy equation anymore, but it's not fractions either. So we'll start simplifying by distributing. So we'll get 3x squared here minus 9x. And on the other side we'll have minus x plus 5. Combining like terms, we'll have 3x squared minus 2x plus 3. And the right hand side still stays as minus x plus 5. It looks like it's quadratic, so in order to solve quadratic, we're going to need to get one side equal to 0, which means I'm going to add x and I'm going to subtract 5 to make this side equal to 0. On the left, we'll still have to add x and subtract 5. Negative 2x plus x is negative x, and 3 minus 5 is negative 2. Now we should see if we can factor it. So 3x squared would factor into 3x and x, and the 2 is going to factor into 2 and 1, minus 3 plus 2. That will give me the negative x that I need in the middle. Solving each of these factors, we see that our solutions are x equals negative 2/3 and x equals positive 1. Go back into the original equation and make sure that none of these solutions are going to make a denominator equal to 0. But the only way that would happen would be if x is equal to 5 or 3. So we're good, and those are the two solutions.